In the West, our perception of humanoid robotics is shaped by viral demonstrations of athletic agility. We watch multi-million-dollar research projects sprint through parkour courses and stick backflips, suspended mid-step over complex obstacle courses. American tech giants are designing these machines as sophisticated, high-end artificial intelligence platforms. They are built to be the most intelligent entities on the production floor. This chart reveals the disconnect between R&D fame and actual adoption. While the United States has roughly 10,000 robots actively deployed, China has already pushed past 250,000. The United States is fiercely focused on winning the software race for artificial intelligence. China is winning the physical deployment war. Modern Chinese factory floors are actively rotating human workers out of assembly lines in favor of automated systems. Domestic robotics firms are preparing to ship up to 20,000 humanoid units this year, pricing them under $5,000 apiece. At the same time, specialized facilities are scaling to produce 10,000 units annually. This strategy mirrors the approach that allowed China to dominate the global electric vehicle market. Rather than waiting for flawless artificial intelligence, the government is subsidizing a hardware supply chain intended to flood the global market through sheer scale. China's robotics expansion follows a top-down mandate driven by central government initiatives like the Robot Plus Application Action Plan and Made in China 2025. The primary mechanism used to force this market shift is the demand-side subsidy. This graph illustrates industrial robot densities. China's dark red line shoots upward from 2015, overtaking the world average, the US, and Japan by 2021. By covering up to 30% of robot costs, the state forces large enterprises to automate rapidly or risk losing state support. This rapid adoption creates a self-reinforcing industrial machine. The mandates guarantee massive domestic demand, providing a guaranteed market for local robotics startups. To support this demand, China has established 6 major humanoid innovation centers, turning regions like Shanghai into physical hubs for hardware development. State-backed companies are localizing the supply chain, stripping away their historical reliance on foreign imports for specialized robotic parts. Today, Chinese manufacturers can produce key components, like harmonic reducers and servo motors, for at least 50% less than Western competitors. That localized efficiency leads to a staggering cost asymmetry. The Boston Dynamics Atlas costs an estimated $420,000. China's commercially available Unitree G1 starts at just $16,000. Organizations can buy 26 mass-produced Chinese robots for the price of a single Atlas. This low cost removes the barrier to entry, allowing smaller manufacturers and independent researchers worldwide to acquire full humanoid platforms. While Western engineers are handcrafting the bespoke Ferraris of robotics, China has already built the affordable Model T. The United States currently maintains a lead in software, specifically in training VLA, or Vision Language Action models, which grant robots complex reasoning skills. To close this gap, Chinese tech giants are leaning on their expertise in consumer electronics and automated manufacturing. Smartphone maker Xiaomi recently took their Cyber One humanoid out of the lab and placed it directly onto their Beijing EV assembly lines to handle real-world tasks like sorting metal parts. These machines are already matching the aggressive 76-second factory cycle times required to keep pace with human workers. By deploying robots onto active assembly lines immediately, China allows its AI to fail and iterate in real-world environments, turning massive hardware scale into a feedback loop of data that pure simulation cannot match. The software architectures driving our most advanced technologies are converging. The neural networks used for autonomous vehicles are rapidly merging with the intelligence required to operate humanoid robots. As Western companies push to lower their own robot prices toward the $20,000 threshold, they face a severe supply chain reality. Major players pushing for mass commercialization will likely be forced to rely on the cheaper Chinese component supply chain to hit their price targets, unless that strategy is disrupted by aggressive US trade tariffs. To achieve affordable mass commercialization, the United States must plug into the very Chinese industrial machine it is trying to outcompete. This race comes down to a core asymmetry. It is the pursuit of a singular, perfect, highly intelligent machine, pitted against the deployment of an endless, affordable fleet. China is betting that an army of good enough robots can saturate global manufacturing floors, while higher-end Western prototypes are still being refined in the laboratory. We are about to find out if the victor will be defined by the quality of their innovation
or the overwhelming speed and scale of their manufacturing.